So continuing on with homework 5 or assignment 5, I guess I changed them names. I called homework here and assignment here and whatever. But problem 2 was basically creating a pad stack for the SO2, the SOT23 package for the TLV2401. So let me download the TLV2401, and unfortunately, this one's a scanned data sheet, so we don't have the ability to jump all the way down by clicking on the link. So I'm just going to scroll all the way down. And now, the key thing is we have to find the SOT23, which right here, that's the SOT23. And again, I can tell that it's a surface mount component because of the way that this is somewhat parallel, or in line I should say, maybe is a better word, with the bottom of the component. And also you can tell it's a surface mount because of the land pattern that it is here. Now what's great about this one is there's no computations to do whatsoever. We literally just have what it is here. And so this is a rectangular pad and it's a surface mount pad. How do I know it's a surface mount? Well, again, I'm not drilling a hole through this. And so we're going to go ahead and just start a new pad stack. And I'm going to just save it in my dpadstacks directory. And instead of saying through pin, I'm going to do SMD. Also, you'll see SMT as well, but SMD is surface mount device, so I'll do that. And the name here, well, I'm just going to do test for now. I'm going to have to rename it, but I'm going to just save it as test for now because I don't know the naming convention yet of what I'm going to do. It'll be easier once I've created the pin to know that, so I'll have to resave it here. All right, so SMD Default Geometry. Well, let's see here. You can kind of see here. Let me blow it up here. When you zoom in, these are rounded rectangles. And so if they're rounded rectangles, obviously I'd want to choose the rounded rectangle. Now, if you go to drill, it's saying no hole type because, well, again, this is surface mount. So I go straight to the design layer. And because it's a surface mount, you only literally have the top layer where you have to do the etch pad. And the dimensions are literally right here. These, in my opinion, the surface mount pads are the easiest pad stacks to define because it's 1.1 by 0.6. Now, the good news about these, again, is that this is going to be a standard size pad stack that we're going to have to use for other types of components. So let's go ahead and do begin layer, regular pad here, rounded rectangle. And so, okay, well, its height is 0.6, and I'm assuming those are millimeters. What's here says millimeters. So it's actually, is it on the previous page here? Okay, all linear. I was going to say, where's it telling you the dimensions? All linear dimensions are millimeters, and so it's saying notes 1, and so that's actually continued on for this page as well. And so 0.6 millimeters for the height, and then the width here is 1.1 millimeters. And I'm still in millimeters, of course. And so it's rounded, and then the corner radius is 0.05. And then it says, okay, for the mask layers, the 0.07 all the way around. So again, there's 0.07 on the left-hand side, 0.07 on the right-hand side. So, well, we just gonna do, again, there's only solder mask on the top, rounded rectangular. Well, the width here is now going to be increased by 0.14 because we have 0.07 on one side, 0.07 on the other. So I'd have 0.6 plus 0.14. So that would be 0.74. And then the height would be 1.1 plus 0.14, so 1.24. And then the rounded rectangle, the roundedness of that rectangle is going to still be the same, so 0.05. So that's my solder mask. Now I need to do my paste mask. Now in this case, I know in another video I had said, well, do a 10% reduction for the paste mask. That's great. If you do a 10% reduction, that is 100% fine. In this example though, it's actually doing based off of a particular thickness of stencil, and they even say board assembly site might have different recommendations for stencil design. So that's what this stencil design is what it's talking, because it's the solder paste for the stencil design. And so we're just going to go with the recommendation here. But depending on, again, the board assembly site might have different recommendations. It might be based off of the type of solder that they're using. Because there's actually more than one type of solder that you can use for solder paste. So width is not 1.1, it is 0.6. Height is 1.1. And the rounded is 0.05. Actually, I did have those correct here. I put them backwards. Width is 1.1. Height is 0.6. There we go, that's looking better. And now we're ready to save it. So again, I don't remember all of my naming conventions, so let's go here and see if there's an example. Well, here's a rounded, not a rounded, here's a rectangular SMT. What's this one? Oh, rounded rectangle, 2 millimeter by 1 millimeter with a 0.05 millimeter radius corners. Oh, perfect. So let's save. Well, I saved it, forgot to actually do what I said we needed to do, is change the name. So I'm going to do save as, and instead of calling it test, I'm going to do it's R for rectangular, and it's going to be 200 underscore 1. I'm copying what's in there. It's the land length by the width, and so this is of course where it's going to get, the naming here gets a little bit confusing here. Is so it said, I was looking at a line here, but the larger, so basically what we think of as the width goes first, and what we think of as the height goes second. So we'll do rectangular, and our width is 1.1. Our height is 0.6, so 60. R for rounded rectangle, 5, because it's got a 0.05 millimeter corner radius. And now I've created the footprint. And so I'm actually going to pause the video here because I have a meeting I got to go to, and then I'm going to come back and finish this video. And so it's going to possibly look a little bit weird because it might have a weird jump in it, but just know that's why this is happening. Okay, so there's probably a tiny bit of jump, like I said there would be in this video. And so we did the TLV 2401, and that my recording window is not all the way up there. That was what we named the R110 60 R5, 1.1 millimeters wide, 0.6 millimeters high, rounded corner of a 0.05 radius. All right, so we've got one more we need to do for this particular assignment, and it's for this stereo amplifier. So again, this one doesn't have a nice clickable one, but how I can know that this is a through-hole component is if I just look here, obviously if you laid it this way, it's not going to surface mount, but you can just even see the way these pins are kind of configured. How would you mount that such that you could wire up all these pins on the surface of a board? And there's no way you could do that. The only option is that you have to put those pins through the board. So that means we're going to have to do a through-hole pad stack. And down here, now the reason I picked this particular component is that sometimes components are like this, and I'm not a big fan of it like this. Some people prefer it this way. I don't like it because it's like you have to, look here and then go back up to the table. And so we'll go ahead and use here now. We'll go ahead and use the maximum again. You could use minimum if you wanted to. I'm not going to be horribly picky on that, but we have to drill a hole. So if we're going to drill a hole, we first need to know my maximum hole size. So let's do this again here. Move that aside. Okay, so I'm just going to go ahead and do these here because we know we have a rectangular pin again. We can kind of see that's rectangular. So I have to figure out my maximum diameter, or just my diameter, I should say. I didn't recognize that was still on the green pen there. It doesn't really matter. So we need to compute this dimension D here. Now let's look at this dimension here that's going from left to right here. Well, if I look here, that is F. And so I have to come back up here, look at F, and, well, what is this in? Okay, millimeters and inches, but we're going to be doing millimeters. So the maximum is 0.95. And then I need to find the width of this, which if I look, it's dimension E, which is 0.55. And so I would have that my maximum, my lead diameter, or maximum lead diameter, whatever we think about it, 0.95 squared plus 0.55 squared, and the square root of that. And if I do that, let's see here, let me bring up my calculator again. If I do that, we have 0.95 squared plus 0.55 squared. And what does that equal? 1.205. Do the square root of that, and we could, since we're doing, 4 decimals, we could keep that, but we know we're going to be approximating this anyway for the hole size. So I'm just going to go ahead and round that to 1.1 millimeters. And so then for level A, again, which is what we're doing unless otherwise specified, level A, my pad, my hole size is D plus 0.25. So this would be 1.1 plus 0.25. I want to double check on that again. For some reason I'm thinking I'm saying something wrong. No, it's 0.25. And so that would be 1.35. Now, again, we wouldn't have a 1.35 millimeter drill bit, but we would have a 1.4 millimeter drill bit that we could do. So I'm going to round this to 1.4 millimeters for the whole size. Actually, I don't know, we technically have a 1.4, but when they get to the bigger sizes, you can still go in the 0.1 increments. What our router, our board has the ability to do is it actually will like drill a 1 millimeter hole, and then it will take a little contour router and stick it into that 1 millimeter hole and then enlarge it to 1.4 millimeters. It's kind of cool to see work, but so you can actually do, even though we might not have a 1.4 millimeter drill bit, we'll still be able to do that. But the key thing is just remember to go in tenths of a millimeter for your hole size. All right, now let's do the pad size. Again, for level A, just like we discussed in the previous video, we can just think of this as 1.44 millimeters plus 0.7 millimeters because it's that plus 0.1 plus 0.6. So if my arithmetic is correct, that would be 2.1 millimeters. And then for the mask layers, I would have, for my solder mask layer, I add that 0.14. So I'd have 2.1 millimeters plus 0.14 millimeters, 2.24 millimeters. And let me circle this here. So now I have my 3 dimensions I need to do my pad stack. So let me move this over here, go here, and now I can do a new and through-pit. Now I actually already know the naming convention I could do for this. I'm going to do a circular hole, and the pad size is 2.1 millimeters, so 210, and then the hole size is 1.4, so that's 140, and that's it. So that's going to be the name of my pin. Default geometry of circle, I'm still in millimeters. I'm going to go to drill. Finish diameter, 1.4. We're never going to be using these in our class. That's for some advanced stuff that we won't use. Except drill symbol. I almost always forget that. We need the drill symbol, 1.4. Again, that gives me that black outline. Then my mask layers. Solder top mask, circle. I'm actually kind of going a little bit out of order. That's fine. 2.24. Solder mask bottom, circle, 2.24. And let's go back and do the design layers, which I skipped. Circle, diameter 2.1, circle, diameter 2.1, circle, diameter 2.1. And so I'll just save again, and we have our pad stack. So we now have done the 3 problems from the homework. So let me actually bring up my Explorer here. I just want to show you something to see if it happens to me. So let's go to the OneDrive, and What am I doing here? Actually, I saved these on my D drive. Cadence. Actually, I did a D pad stacks. I'm going to do date modified because these gives me. I'm going to reopen this one here. And in this case, it did actually hold my 1.74. I was curious if it would. So it did hold it there for me. As I said, I know that some people have had it hold there. If that it doesn't save that for them, and when they open it again, it's gone, and it's like rounded it to 1.7. If you feel like you've had that happen to you, please email me, and I will go back and look at your assignment again. All right, but that gives us the solutions for this assignment. So hopefully that will help you also with assignment 7, because assignment 7 is still making pad stacks. We just aren't going to have all of the design layers because, or we have different design layers because we're doing vias and also we're doing mounting holes, but the process is still the same. And as far as sizing them, it's, make sure to watch and take notes on the videos as far as doing the dimensioning on the sizes for them.